Okay, so far we have already done differentiation, which is chapter 14. Okay, now we're moving on to 15.1, tangents and normals. Okay, first and foremost, right, we learned that when you differentiate a function y for the first time, you actually get the gradient at different points. Okay, so you can actually find the gradient of the tangent at the specific point of a certain graph that you need. Okay, without much further ado, let me just give you an example of question 1a. Okay, of exercise 15.1. 1a, they give you the function is y equals to x cubed plus 3x squared. And they tell you that they want you to find the equation of tangent of the curve at the given point. Okay, let me just use a Graphmatica now, okay, to show you this function, x cubed plus 3x squared. Okay, so first y equals to x cube plus 3x square. Okay, then I press enter, and this is the curve. Okay, and they want the equation of tangent at -1 and 2. Okay, so first and foremost, what I do here is this. First, I will use calculus. Okay, draw a tangent. Okay, x equals to -1. Okay, x equals to -1 will be down here. X equals to -1. So basically what they want you to do is like that. Alright, so what happens is they want you to find the equation of this line. So there is the curve. Okay, so we will actually try to find the equation of this tangent. Okay, already, right, if you look at down here, the tangent line is y equals to 3x minus -3x minus 1, as shown from this diagram over here. Okay, never mind, let me try to zoom out a bit. Okay, so we're trying to find this tangent line down here. Okay, now let's see how we can actually calculate it, right, without using Graphmatica. So let me just go back to this one. So first, right, we try to find the gradient, okay, of the tangent at that point. So first we differentiate is 3x squared plus 6x. Okay, to find the gradient at that tangent point, alright, what I do is I let x equals to -1. So I get 3 times -1 squared plus 6 times -1. So my gradient is 3 minus 6, it is -3. So far so good. Okay, now next part is this. I form my equation. Okay, now notice that I want to find, right, the tangent at the point -1 and 2. Okay, so I form, as we learned from E-maths, the equation of a line. Okay, in this case, the equation of tangent is y equals to mx plus c. So it's -3x plus c. How do I find c? Okay, I'll just simply substitute x equals to -1, y equals to 2. 2 equals to -3 times -1, alright, plus c. c will be equals to -1. And therefore, my equation of tangent is y equals to -3x minus 1. Quite easily done for question 1a. Let's check to see if my answer is correct, and if you notice from down here, y is indeed equals to -3x minus 1. So the calculation is correct. Alright, now we move on to the next question, okay, which is question 2a. Okay, let me get back to the presenter. Okay, question 2a, what they give you is the graph is y equals to x cubed minus 5x plus 8, okay, where x equals to 1. Okay, first and foremost, be very careful in this case. If you read the question carefully, what they actually want you to find is the equation of the normal. Okay, let's go back to Graphmatica now. Okay, so I clear screen first. Okay, first I key in the equation y equals to x cubed minus 5x plus 8. Okay, let me zoom out. This graph is a bit... Okay, I zoom out. So first and foremost, I draw a tangent, okay, at the point. Okay, the point is x equals to 1. We find x equals to 1, which is down here. X equals to 1. Ta-da! And I find that my tangent line is y equals to negative 2x plus 6. But be very careful, what you're looking for here is not the tangent line, okay, but the equation of the normal. But just bear in mind that this is the tangent line down here. I will find the equation of normal for you in a short moment. So first and foremost, what I do here is this. I differentiate with respect to x. I get 3x squared minus 5. Then my gradient of my tangent, where x equals to 1, is 3 times 1 squared minus 5. My gradient is negative 2. But be very careful down here, because what we actually want to find is the equation of normal. If we learn, okay, we know that the gradient, the product of gradients, okay, so this one, m1 times m2 equals negative 1, is to find the gradient of the normal. So I just say negative 2 times m2 equals to negative 1. m2 equals to half. So I can say that the gradient of normal is equals to half. Okay, before you go and find the gradient of normal, notice that once the equation of normal rather, you will actually find that you need a value of x and a value of y. So before I even start, right, you go to find the equation of the normal. Notice that when x equals to 1, there's a y value missing. How do I get the y value at the point? I substitute x equals to 1 into the original equation. So I say here, I sub x equals to 1 into y equals to x cubed minus 5x plus 8. And I can get my corresponding y value. My corresponding y value is 1 minus 5 negative 4 plus 8. My y value is equals to 4. Okay, so now I try to find the equation of my normal. Okay, so I say equation of normal. Okay, I say y equals to m x plus c. Now I substitute x is equals to 1. Corresponding y value equals to 4. So 4 equals to half times 1 plus c. C is equals to 3 and a half. So therefore the equation of my normal is y equals to half x plus 7 over 2. If you want to make it look nicer, you can multiply everything by 2. You get 2y equals to x plus 7. And that is the equation of my normal for question 2a. Now I present to you another example, which is question